See if Ry is ready.
All right, we're live. Hi, everybody. Welcome to today's Logstash Work-with-me and AMA. We're going to just take a second to get things set up.
All right. Just checking to make sure that the content there is still good. And that everyone, we're both live at the same time. Good.
Sorry about that. We have multiple streams streaming to the channel right now, a thing that we have never done before. So we needed to make sure that everything was set and that we didn't bump our colleague off the channel. But all right.
All right, cool. I'm gonna add Ry in. Hey Ry, how's it going?
Hello, it's going quite all right.
Good. I'm glad we were double checking some things and making sure that apparently we have two live streams happening at the exact same time.
Competition, great.
Exactly. So, I mean, obviously we know which one is the better live stream, but you should check out both. Just watch ours live and then go check out the VOD later of the other
Indeed.
one. Awesome. Well, I am just sharing that we are live. And then after that, I'm going to kick in the countdown timer and then we will get started.
Sounds good.
All right. All right. And from there, let's see. I'm going to get our nice little branding thing going. And if I can find it. All right, here we go. Ready? Hi, everybody. Welcome to the Elastic live stream, or I guess I would call it the Elastic Live user group. I'm Jay Miller. I'm a developer advocate for Elastic, and I am here this week with my fellow teammate, someone who I have definitely heard talk about this before in the most understandable and passionate of ways. Ry. Ry, how are you doing?
Hello, doing all right.
Awesome. Well, let's kick this off by first having you introduce yourself, telling people what you do with Elastic, and just anything that you think that other people would really enjoy to know about you.
Sure. I'm an engineer on the Logstash team. We maintain Logstash core and about 200 plugins. So we've got a real large surface area of different technologies we interact with, and so my work life is playing whack-a-mole with all of the different things that we're doing, and making sure that we're staying on top of when new data streams start to come through, that we have the plugins to support them and understand them, and that our existing plugins support those new use cases and stuff like that. In real life, I'm a dad, both to a child and a dog. The child gets a lot more attention these days, as you do. I live in Seattle, Washington, and I like woodworking.
So I will warn people, you have two dads on the stream, so children may run in, words may be exchanged. Who knows? We'll do our best here. But the fact that you're in Seattle, I tell people Seattle's like my home away from home. I'm down in San Diego, but I love the Seattle area. Especially, I love getting burgers at Dick's. Like, I think that's like one of my favorite things to do. And then, of course, just hanging out on the ferry or traveling to like Bainbridge Island. So yeah, how have you always been a Seattle native, or?
I've been here about a dozen years, so
Okay.
my adult life has been all up here.
Awesome. Awesome. Well, we're here to talk about Logstash. I the story that I have for Logstash is that when I started at Elastic, my first goal was to reach out to as many people that I knew that were using the Elastic stack, and almost everyone that I talked to had the same question, and it was, what's Logstash? Like, what is that? Where is its place? What is it? What's going on there? So I'm gonna start with that question. What is Logstash, and how does it fit in the stack?
Yeah, I think I'll go into a lot more detail when I get to the slides demo. I've actually got some of that overview in there, but Logstash is a data transformation pipeline. It is a jack of all trades for data transformation, enrichment, and ingestion. It might be complex, but you can make it do just about anything that you need to get done. There are a lot of use cases for which Elastic has built simple, streamlined solutions that you can just like configure with 3 lines and just go. This isn't one of those. And if you can make your life work with one of those, absolutely do it. We won't be offended. But if you need to enrich inbound data with external context or parse complex input that isn't covered by a simpler solution, that's what Logstash is here for.
I've seen some of the plugins that we support, and I've used a lot of them. I think my first like mini Elastic project was like an RSS reader that was using Logstash as RSS input. And just, I mean, one, people don't try to build your own apps. There are great apps out there. I mean, if that's your thing, by all means, but you're giving yourself more things to support aside from all of your responsibilities like dad life. So but still, it was great to see how simple ingestion could be, and even like doing things like fingerprinting and like mutating data to fit the scheme. Like, I thought that was super cool. But I do wonder, you talk about there's so many use cases. Is there one that kind of stands out for you when it comes to using Logstash?
So I stopped being a user of Logstash about 3.5 years ago when I joined Elastic. Before that, my team had done your standard ELK. It was before Beats, and so we did use it to parse log files, to pull them in, to get them fired through with Logstash Forwarder and Redis, and back to real Logstash, and then out to Elasticsearch and hope and pray that everything works. Things have gotten a lot better on just that flow, but also with Beats and stuff like that. But one of the more impressive workflows that I've seen at like other AMAs is when people do secondary enrichment, where they are getting their data into Elasticsearch as raw and as minimally as possible first, and then are running a Logstash pipeline to query recent data, to perform the enrichments, and then persist those enrichments as updates to the record. So that way they're able to kind of decouple their ingest pipeline and their enrichment, so that if they have an enrichment service that is down, they're still able to get the minimal data in near real time. And they're able to not have to lag absolutely everything just because one of those non-necessary enrichments is taking a little longer.
Oh, let me fix that really quick. There we go. That makes a lot of sense to me. And it's interesting that as I learn more and more about Logstash, I do always still want to kind of lean in that direction. Like, I know we have all of those things. We have file beat, metric beat, like we have all of the beats. I mean, we probably have Beats headphones somewhere, in a warehouse, but it's interesting that just the simple flow of like input, output, and some things in the middle just makes sense, at least in my brain. Do you think that that's one of the reasons why people hold on to Logstash, and that they do think about it as much as they do?
Yeah, the simple use cases are simple. It also can do those horrifically complex things that you need it to do and can't find a better way for. And so being able to span that whole gamut, I think, is really important. And that's why Elastic has Logstash. That's why we continue to invest in it and move it forward. Is like, it's not the place for refined end-to-end solutions. It's the place for the messy. It's the place for, we need something that a user who is familiar with the business logic can manipulate without having to worry about all of the streaming complexities and the, all of the complexities of doing things at scale. You just have to look at a single pipeline of data.
Speaking of pipelines, I want to talk about what's coming down the pipeline for Logstash. A lot of people are always asking, like, what's going on, what's new with Logstash, and I got to hear a little bit of some of the plans, but I think you said you brought something to kind of show us to go along with that.
Yeah, I've got some slides up. If you can start presenting those, we can move into that. It's about a 20-minute presentation, and it's going to roll a little fast.
Let me make sure that I've got you as the person here. You're going to see some movement happening, but fear not, Jay's on it. Okay, there we go. We're going to go with this one.
Cool. All right, so today we're going to talk about Logstash and what we're doing to make it easier to adopt the Elastic Common Schema. The slide deck for this talk contains a number of code that are meant to visually convey complexity, and we won't have time to read through them line by line. All the presented configs and inputs will be made available for you to play with later. Introduction. Hi, I'm Ry Biesemeyer, one of the principal engineers working on the Logstash project. Logstash is a tool that facilitates user-defined pipelines for transforming and enriching a stream of events. Our users define these pipelines using a domain-specific language to connect input plugins with codec plugins through a sequence of filter plugins to output plugins. You didn't notice a theme. It's really all about the plugins. But what are plugins? Input plugins create events, often with the help of codec plugins. We use these to connect to inbound queues, data sources, etc. Codec plugins transform an arbitrary sequence of bytes into a structured event. That way we can handle the same type of input regardless of where it's coming from. Filter plugins transform and enrich batches of events, and output plugins persist batches of events elsewhere. On screen, you'll see a simple pipeline definition. It includes a single TCP input plugin that uses the Ceph codec to create events from inbound data, a couple of filters that batches of events are conditionally routed to in sequence, and a single Elasticsearch output plugin. In the real world, pipeline configurations can grow to be thousands of lines and can invoke a sequence of hundreds of plugins with layered conditional logic to mutate and enrich events before eventually routing them to outputs like Elasticsearch, S3, or even other Logstash pipelines. And while Logstash is a part of the Elastic Stack, we know that not every Logstash pipeline in the real world routes to Elasticsearch. We're here for those too. Logstash is powered by its plugin ecosystem. Plugins are versioned and packaged independently and are completely independent of the Elastic Stack release versioning. This empowers us to release fixes to plugins outside the Elastic Stack release cadence, and for our users to get fixes to individual plugins without upgrading Logstash itself. Historically, there was no single standard for how a plugin enriches data. Many plugins originated as donations to the Logstash project from outside sources, and the more widely they were adopted, the harder they became to change. While some plugins require explicit configuration for absolutely everything, many implicitly populate events on the event in their own way. This can lead to schema conflicts when certain plugins are used in combination with each other, or when they target an Elasticsearch index that also contains data from another source. As the Elastic Stack has evolved, we've discovered that when data from many sources fit into a common schema, each source becomes a value multiplier. For example, we can correlate events indicating high latency to a destination address with other events that have CPU or memory metrics about that host. We leverage shared schema heavily in the Elastic observability dashboards. The Elastic Common Schema is a community-driven schema that allows us to encode the semantic meaning of a field into the field's name, so that when two or more data sources describe the same thing, they can be used together. We have long wanted to move to a world where a brand new Logstash user gets ECS compatible events by default without having to manually remap each and every field produced by their incoming data. But more importantly, we needed to avoid breaking existing pipelines. This is a part of why Logstash is a little late to the game of adopting ECS. I'd like to show you 3 simple demos to set a baseline for behavior. We're looking mainly to show complexity, but these scripts will be made available after the talk. Here, we'll be parsing some log lines encoded in the common event format, or CEF. Our example input is very long with many extension fields. And our pipeline config is pretty straightforward. Our regular input uses the CEF codec, and the rest is boilerplate to make it work with my demo capture tool. We run Logstash. And as you can see, the resulting structured event is flat and very CEF-centric. It won't mix well with other data sources and has ECS conflicts like the top-level host field. Okay, next we have a simple GeoIP enrichment. I've set us up with the simplest of inputs, and our pipeline is pretty straightforward too. I'm going to run Logstash. And the results are an event with the top-level GeoIP field, which doesn't have any context as to what it's referring to. The shape of the GeoIP field isn't quite ECS either. Okay, finally we have a simple grok extraction. Here we have 2 inputs, an HA proxy log and a generic access log, and we can scroll and see that the HA proxy log is pretty long. Our pipeline includes a grok filter that matches for either. And easy enough, we get an explosion of top-level fields, including a lot of useless ones like HA proxy's timestamps, individual hour, minute, and second fields. It's a big flat mess. We can scroll down to the other event and see that it too is flat and has ECS conflicts like that troublesome top-level host. All right. In Logstash 7, it's certainly possible to transform a pipeline of events so that each is ECS compatible, but it is not pretty. Many plugins implicitly violate ECS by populating fields without any explicit instructions. So ensuring your pipeline produces ECS compatible events typically entails a lot of cleanup work. Let's take a look again. The text on the screen is to demonstrate complexity, and the code will be made available. Let's do it on our own. We'll repeat the CEF demo, but with manual ECS remapping this time. We're using the same CEF-encoded logline from last time, but this time our pipeline config is a lot more complex. We add filters to clean up after the standard in input, more filters to remap the CEF header fields into ECS compatible fields, more mutate filters to remap the various extension fields from our input, and this would be much longer if it mapped all of the CEF extensions. Here we're just focusing on the ones from this particular logline. We also add some date filters to parse out the timestamps and get some meaning of those. As you can see, the pipeline has gotten pretty complicated. But we can run Logstash. And we end up with a nicely nested ECS compatible event, complete with CEF-specific namespace for CEF-specific fields. All right, next up, we'll repeat the GeoIP enrichment in an ECS manner. We have a sample input, same as last time, and a more complex pipeline to do the remapping. We target the results of our GeoIP lookup to a metadata field so we can avoid populating or polluting the top-level namespace. And then we go through and remap the fields one by one. And even though metadata fields aren't included in our output, we clean up after ourselves. This is a good practice for long-lived pipelines, so make sure that events take up as little space as necessary as quickly as possible. But our result is ECS geo object that's properly nested underneath the host whose IP we looked up. It's geo and it's ECS. All right, finally, let's repeat the Grok demo with manual ECS. This one gets a little hairy. Again, we'll use the same inputs as last time. And let's get started. First, we clean up metadata from our input and move the message out of the way to event original, because we know that Grok captures to message. But then things get really complex. The cleanup is pattern specific, so we can no longer use a single Grok filter to fall through a sequence of patterns. We have to handle them one at a time. And when I say complex, I really mean it. We have to remap a lot of fields. We have to remove useless captures and do a whole bunch of conversions. But that's just for the first pattern. We then need to attempt other patterns if we haven't succeeded yet. And we have to clean those up too. And then if we exceed at making one match, we need to parse the timestamp too. And that's just for 2 patterns. The wider the variety of logs you parse, the more complex this gets. It's obviously not manageable. But we can run the pipeline, and we end up with nicely structured events, including namespacing for vendor-specific metrics, and all of the top-level ECS fields. As you can see, even with these simple use cases, complying with ECS requires verbose pipeline definitions. It makes those pipelines harder to maintain and introduces more opportunity for human error. We wanted to obviate the need for this cleanup. We wanted ECS-compliant pipelines to be simpler and more readable, to eliminate the overhead of ECS without forcing our users into a specific schema. We know that ECS by default was the right solution for new users and new pipelines, but we also knew that our solution needed to work for our existing users and their body of pipeline definitions, providing a simple opt-out for users who maintain complex pipelines that they can't afford to change, and a process for migrating existing pipelines for those that desire to do so. Importantly, we wanted to make this independent of the Logstash 8 upgrade itself so that it didn't become a barrier to upgrades. The faster our users upgrade to Logstash 8, the less effort we will need to expend maintaining Logstash 7. In Logstash 7.10, we introduced an option called ECS Pipeline Compatibility to the plugin API, powered by a new setting, pipeline.ecs compatibility, that can be specified for an individual pipeline in the pipeline's YAML or globally in Logstash YAML. This API bridges the gap between plugin maintainers and our users who are defining pipelines. Logstash users can use this API to specify in which mode a plugin should be run, for an individual plugin instance, for an entire pipeline, or globally. And then pipeline maintainers can query this API during plugin initialization to determine the effective mode in which the plugin should be run. We then released a support adapter which provides a simplified implementation of this API so that when a plugin is run on an older Logstash, the plugin can continue to work. And since that older version of Logstash doesn't provide the pipeline level setting, it's simply off by default. This approach eliminates the risk and overhead of maintaining separate implementations in separate branches in each of dozens of separate plugin repositories. We also added tooling to the support adapter to make side-by-side implementations in plugins easier to author, maintain, and test. Then we got to work implementing ECS compatibility modes in a host of plugins. There were a few different classes of problems to solve. Some plugins needed to change the metadata shape. The UDP and TCP inputs, for example, record metadata about the host and port that sent the payload. The file input records metadata about the source file's path. The Kafka and RabbitMQ inputs add metadata about the topic or queue that we received the event from, and so on. We need to make sure that that's done in a standardized way. Some plugins needed to change the implicit schema, like the GeoIP filter that we've seen, should use the ECS's geotype and should also target the result to somewhere meaningful. The Ceph codec should use the Elastic standardized Ceph mapping, the same as Beats and Agent, so that it can work with our observability dashboards. Some plugins needed to add an optional target to allow users to declaratively place the results somewhere specific instead of populating top-level fields that are likely to clash with ECS. The JSON and CSV filters and codecs populate fields defined in the payload that aren't necessarily known when the plugin starts up. And plugins like the JDBC and Elasticsearch inputs take the results of a query, and a target can be helpful there too. And then the grok filter was in a class of its own. It needed a massive overhaul of all of its sub-pattern captures. We had to understand the semantic meaning of each capture so that we could appropriately route it to the right ECS field. When solving these problems, we are implementing ECS compatibility alongside each of the existing implementations. Each plugin has automated tests that ensure it is capable of behaving exactly as it did before we introduced this optional mode. We have made good progress and are steaming forward. As of yesterday, of the 61 Elastic-supported plugins identified for inclusion in the effort, 23 were identified as no-op, meaning they made no implicit modifications to the event. 22 are done and now have a new ECS compatibility mode. 6 are in progress, 6 are fully scoped, and 4 remain with limited scope. We can use these plugins in ECS compatibility mode in Logstash 7 to define simple ECS compatible pipelines without the complex remapping. The following examples require opting in for the pipeline, which is beta until the final release of Logstash 7. We've set the global pipeline ECS compatibility, so let's run through the same demos and get ECS compatible events more simply. We start again with the Ceph example. We have the exact same log line, and our config is actually simple again, just the Ceph codec in the input and the boilerplate to make it work with my demo. When we run Logstash, we end up with an ECS compatible event, simply. We'll do the GeoIP enrichment again, this time with ECS compatibility globally enabled. The same sample input as last time, but our config is simple again. We run Logstash, and the enrichment is ECS compatible, nested on our host, proper geo field. And finally, we'll do some ECS compatible grok parsing. This is the one that got horrifically hairy. So we'll use the same sample inputs as last time. And our config is back to being pretty simple. We can regroup the separate grok matches into a single filter instance, and we don't need to worry about anything else, really. When we run the pipeline, the results are ECS just as we expect them to be. As you can see, we have ECS simply. One thing to note, as we continue to approach the final minor release of Logstash 7 and the upcoming major release of Logstash 8, the scope of ECS V8 is coming into focus, and we're adding ECS compatibility modes to more plugins. While it is possible to opt into ECS for a whole pipeline or globally right now, doing so is considered beta and has some sharp edges, especially across minor upgrades of Logstash. All right, migration. In Logstash 8, ECS will be on by default. This means that each and every plugin that implements an ECS compatibility mode will operate in ECS unless configured otherwise. We want you to be confident in your upgrade path to Logstash 8. As a maintainer of Logstash pipelines, what does this mean for you? When it is time to upgrade to Logstash 8, we encourage you to first upgrade to the final release of Logstash 7. We call it 7.final. Upgrades within the 7 series are non-breaking and will ensure that you have a chance to resolve any deprecation warnings before doing the major version upgrade. Beginning with Logstash 7.10 and through the rest of the 7 series, we emit an entry to the deprecation logger when a plugin attempts to use the ECS compatibility mode and the pipeline has not defined it. We want you to know that your existing configuration is in danger of breaking at the next major upgrade and to give you a chance to fix it first. If you run multiple pipelines, adding pipeline ECS compatibility disabled to a pipeline's definition during the 7 series will ensure that all plugins in the pipeline default to ECS compatibility being disabled. This effectively locks in the existing behavior of 7x and resolves the deprecation warning. If you do this and then upgrade to Logstash 8, your pipeline will continue operating exactly as it did before. If you would like to migrate a pipeline to use ECS and to gain the benefits of a common schema, it may be helpful to instead resolve the deprecation warnings one plugin at a time in a development environment. To do this, you'll need to understand how running in an ECS compatibility mode changes the behavior of each individual plugin. We encourage you to read the docs. We have tables and callouts. We worked real hard on it. You'll also need to resolve any downstream effects in your pipeline. For example, if you configure an instance of the Ceph codec to run in ECS compatibility mode, a downstream geo-IP filter that enriches the IP address of the Ceph's device address field will instead need to enrich the host IP. But once you've done this, once the deprecation logs have been fully resolved in this manner, and you're running 7 final, you can then specify pipeline ECS compatibility with a real value for the entire pipeline and remove the individual per plugin ECS compatibility declarations. We know that using a common schema for data from disparate sources is the key to unlocking multiplicative value, and hope that you find the Elastic Common Schema to be useful. In Logstash 8, we'll be providing a better default experience for new users with regard to the Elastic Common Schema, and we're doing so without compromising the experience of our existing users who own and maintain complex pipelines or who don't target Elasticsearch at all. We're providing the tools to make the migration to ECS independent of the Logstash 8 upgrade so that our users have the freedom to either lock in their existing behavior or to begin reaping the benefits of ECS during the 7 series. And that's it. Jay, you are muted.
Yep.
There you go.
Again, that is the life of virtual work.
Well, I do appreciate you muting while I was talking.
Well, I was typing, and I have the a clicky keyboard, so I try to make sure I'm not getting in the way there.
Nice.
But I had a few questions, and I also I think we have some questions in chat too, which will, as always, the answer might be it depends. And what we're going to do is, if the answer is it depends, we're going to suggest that you ask the same question in our discussion forum that we have, or in our Slack community as well. But some of the questions that I had, particularly about ECS, one, have you seen a lot of like, I don't want to say frustration, but like a lot of challenges for the plugin providers, becoming ECS compliant or compatible?
Well, our team is the plugin provider. A lot of them were donated to our team years ago, and we maintain them. So our team is steaming forward with the migration, adding these ECS compatibility modes to all these plugins. And it has been largely straightforward. Reading the ECS field reference, where they document the structure and the fields and what they mean. And then we communicate and get kind of sign-offs from the ECS team that's a little more focused on the schema itself, to make sure that, especially when we have things that are not defined in ECS, ECS is also guidelines for how to break it in a safe manner, how to define things that don't fit into the schema in a way that's less likely to break when a new thing is introduced. And so we've been working with the ECS team to get those spot checks, those gut checks. And a lot of it is really well documented in the ECS, on the ECS site itself. And so for us, it's part of it is understanding what the schema means. And then part of it is understanding what the existing captures in the plugins mean. Because we have things like TCP input records a port, right? What does that mean? It's actually the port that we received the payload from, which typically outbound ports are random, so it's not really a useful field, right? But we have to take a step back and actually understand what the current captures mean, so that we can properly map them. In some cases, we determine that they aren't particularly useful, and so we map them onto the metadata. That way they are accessible while you are in the pipeline, but they aren't exported to Elasticsearch or other outputs. So that way, if we did miss something and a user really does need to know what TCP port the TCP input received something from, they have access to it in the pipeline. So that's where the bulk of the challenges are, is just really understanding the schema so that we properly map it.
Cool. And then, I mean, the other question is, we're always trying to become faster and leaner and more performant. Has the addition of ECS, even though obviously, you showed how optimized it is on the user experience, has there been a hit to performance that you've seen?
No, this is it's all at initialization. So there's certainly not a per event overhead. We in the support adapter, we also have some guidelines for implementing it in there, because you have to rely on that support adapter in order to make sure your plugin will continue to work on older log stashes and stuff like that. And yeah, we encourage people not to do not to add overhead per event that we're processing, but to make it part of the initialization. And then, we're talking microseconds of initialization time, and then you're good to go. So yeah, no performance hit.
Awesome. And then the other question that I had is kind of an interesting one. And I see we do have a couple of questions coming into the chat. I'm not quite sure if they're going to be kind of related to what we're talking about with ECS, but maybe we can get to them. The team has provided such a detailed transition process. Obviously, 7. I think it was a 7.8.1, something like that. It was made available, and then now going into 7.9, you're improving it. And as we're getting ready for 8.0 coming down the road, like, you have steps that are like, okay, step 1, upgrade to 7.final. Step 2, like, test everything, make sure it works. Is this, I don't want to say over caution, but is this like, we just want to make sure that everything is looked at, no stone unturned? Go ahead.
Yeah, I can answer that. So traditionally in Elastic, we have recommended that people upgrade to the final release of a major before upgrading to the next major. And the whole reason for that is as we develop and as we introduce breaking changes to the next major, we also introduce deprecation logs to the current major. So that way, by the time somebody gets to the last release of a major, all of the deprecation warnings that alert them to things that could break, that aren't going to just, one-click survive and behave exactly the same way as they did before, that they have the ability to resolve those. So this is just part of how Elastic does things. We want to make sure that users aren't on their own for upgrades, that they have a path forward, that they can be confident in it, that they can run their Logstash and look at that deprecation log and make sure that it's not filling up with things, and be confident that when they go and click that button or replace do a yum upgrade or whatever, that it's just going to work. The same is true with Elasticsearch, Kibana, etc. That's our practice for making sure that people can upgrade safely. Anytime you're doing a major upgrade, there are, by definition, going to be breaking changes. And so anything that we can do to make it so that our users can get that feedback and not just have to manually inspect at all of their stuff and make sure that they're not going to hit these edge cases, that's what we do.
And that to me is reassuring, because that just tells me that, if I'm a beginner in the Elastic stack, obviously there's a pattern. There's step-by-step guidance. The guidance that's provided, is the same, and it's consistent with everything that we do in all of our platforms. So you don't have to worry about okay, this one part of the Elastic stack is like the redheaded stepchild that is actually I should say pinkish purple headed stepchild, I guess. But you don't have to worry about this one thing being so different than everything else. And I'm spoiled because I use Elastic Cloud for most of the things that I'm doing. So for me, upgrading is very much just push the button and it's done. But I can definitely understand how folks that are, seasoned into the process, or that may have gone through a couple of major updates, if that's how we've always done it, then it shouldn't feel very different. And
Yeah.
I think that that's super important.
And this is certainly for the thing that people are used to for on-prem installations of software. And whenever you're doing major upgrades, you have to like pour through the breaking changes notes, and you have to make best guesses, and you might not have all the context to understand that you're going to trigger this breaking change and stuff like that. So anything that we can do to assist our users in the process and make sure that they can go through that company, like, of course, still read the breaking changes log, but we want to add that extra layer.
Definitely, before you come yell at us, read the log. Like read the breaking changes log, please. Oh man. So other question I had is kind of a fun one. I guess a funnish one. It depends on how much you like work. You mentioned that the inputs team is kind of the team, or I guess the Logstash team is the team that is handling a lot of this. What has been your role personally in getting all of this off the ground?
I'm the architect and owner of this project.
So all of it.
Well, no, I've certainly had help. Ry Biesemeyer was the one who did the massive overhaul of the grok filters, and that really, like, that is understanding the context of lots and lots of different log formats and really understanding what we are capturing means so that he can do the remapping. And it was a huge effort. Of course, he had me to spot check him and give him that little LGTM with a thumbs up on the pull request. But massive effort there. I've had help from several teammates. So I've been the one kind of juggling it and making sure that we have this path forward with the easy opt-out. Because, I mean, at the last shop I was at, the people who were maintaining the Logstash installation weren't the ones who understood the business logic, right? Like, they weren't the ones who could just like jump in and change how Logstash was transforming pipelines, right? And so to give people like them the tool to be able to just say, lock in the behavior of this pipeline, just lock it in with a single line that you can add to the config. I know that if I were in that spot, I would need that. And so then a lot of it has just been the orchestrating and how do we make that possible? You know, we didn't have the ability for a plugin at initialization to be able to read the pipeline's settings. That was a problem because we needed to be able to opt out for an individual pipeline, not just globally. And so we added in, the structures to make it possible for that execution context to work its way through to the plugin, so that each plugin you get it. You just get that setting for free.
I wanted to throw that softball out there because I saw Carol in the chat absolutely like being the MVP of this, answering questions that I don't think we were going to be able to get to. But is there anything in particular that you wanna highlight? Something here that you really enjoyed, something that was kind of like your favorite part of working on this?
I think we're finally breaking down a barrier that we've had with plugins. For a while, the plugins were a part of the Logstash code base, and they were broken out roughly 4 years ago to be individual separate plugins so that we could have a lot of those benefits of releasing fixes outside of the Elastic cadence. But doing so created a problem. Those plugins use parts of Logstash directly. There's no like API boundary between them. They are just part of the Ruby runtime. And so we can't really add things to the Logstash API, the plugin API, without those plugins like creating kind of a wall where some of those plugins can't be upgraded. And we really wanted to be able to start introducing these new APIs to Logstash. We wanted to add better validators so that as we're having new types of inputs, like those targets, when we're targeting a field reference, we want to be able to like make sure that at plugin startup that you give us a valid field reference. That way we don't run into problems later on once things have started up. And so we've come up with these ideas for how we can add support adapters that the plugins can use that provide the same API that Logstash Core provides in newer versions, but an approximation of it for plugins that are running on older Logstashes. and finding a way to kind of break that so that we can actually start evolving the plugin API more has been really rewarding. It was a huge challenge, but we've since done it with a number of other support plugins. So we're now having these support plugins for Event Factory is coming soon, so that instead of plugins creating events themselves using the Ruby runtime's event.new, they'll instead have access to an event factory on the plugin itself so that they can use it. And then what we can do on Logstash Core is that we can work to make the event factory better. We can work to make it configurable. We can work to substitute a different implementation of an event factory, that instead of using this event that uses these internals, we can use a different event that uses different internals. And it's starting to kind of unlock the possibilities for what we can do. Whereas without this, we've been blocked on a lot of different fronts.
I love it. So last question from me, and then we'll check to the chat and see if there's any other questions. Again, last call for questions. If you're in the chat, be sure to ask them. Here's the chance. Should I start up that RSS reader again? I want to know. Like, I mean, it was a fun project before, but is Logstash the place where that should live? Should I maybe think of something new for Logstash?
So I think it depends on how long-lived your project is and how complex your project ends up becoming. For your RSS reader, like if it's something to get you off the ground and something to get data transformed quickly and into something that is manageable that you can handle downstream, great. That's great. If it evolves into something that becomes more and more and more complex, that might be a warning sign that there might be a better way, or we might need to design a better way. I really think of that friction of complexity as alarm bells that should be going off, right? For example, a couple of years ago, we were doing some work with Git history on some of our repositories. And so I wrote a one-off Logstash plugin that will crawl a Git log. Its configuration takes a file path to a Git directory, a branch specifier that's optional, and maybe a couple other things. And you hit go, and it will consume the entire log all the way back to the root, all of the changes that resulted in that directory becoming what it became, including every diff. So you have the commit messages, the authors, all of the metadata, and the actual content of what was changed in each of those commits. And that was super helpful to get all that stuff into an index so that we can do some searching. That took less than an hour to write the plugin. And from there, we were able to unleash massive effort. Now, that's not a plugin that I maintain. It's not a plugin that I use on a daily basis, but it was a nice, fast one-off. And Logstash provides a lot of those opportunities.
I think that's one of the things that I definitely want to look at Logstash more for in some of my own projects. And I will say I'm probably just going to check the App Store instead of giving myself another responsibility. But I do love that there is still a home for, for really simple solutions using like the Logstash platform. I always tend to want to think like when I go to the stack, it has to be like this amazingly complex thing, or it needs to be like the overall home of the project. I haven't thought about using Logstash for kind of these, every once in a while type things. And I do have a lot of data that, I mean, I'm reaching out to like Python and learning new Python modules and all this other fancy stuff that, like, to be honest, it just makes me bang my head against the wall more than I probably need to have it do that. So yeah, I do think that I'm going to start looking at some of my existing projects and say, is there a good story here to like just use Logstash for this? And whenever I use it, fire things up, get it running, shut it down, and be cool with it.
Yeah, and so Logstash fills kind of both shoes. It can be a long-running thing that just supports a pipeline that's stable, and it can be rapid prototyping. I really enjoy it for the rapid prototyping, being able to get that rapid feedback when you're using an output like the just outputting the standard out with Ruby debug. Or in my demos, I routed through a JSON formatter because some people are a little more like how the JSON format looks. But I like it for that rapid prototyping and be able to try something, execute it, see if it worked, see if it transformed it the way I expected it to, etc. But then also for some of the more ongoing ones where you might be putting a bunch of logs into RabbitMQ and you need something to consume those and to do some enrichment and stuff. Especially for the enrichment cases there. For the long-lived ones, like if you are going directly from an input directly to an output, you probably don't need Logstash. But if you're doing enrichment, if you're reaching out to external sources to add more data onto the event based on externalized context, Logstash is great as an ongoing pipeline for those things.
Awesome. Well, I think that's going to wrap it up for us. I do see there was one question in there. I don't think this is probably the best place for us to answer that, but I'm sure we do have it written down, and we'll try to make sure we reach out and reply in the best way possible. But in the meantime, Ry, thank you so much for taking a little bit of time and having fun with this. Oh, I think your headphones are...
Yeah, gladly.
Yeah. Do everybody a favor if they want to get in touch with you on social media or whatever you're doing these days. How can people do that?
I'm not on social that much these days. My handle is YAAUIE, pretty much everywhere. There should be a link to the demo content in the video's description. I'll also be adding it to the slides that we should be making available. And yeah, there's my handle right there. I'm glad to respond, but I am a busy dad and busy with work stuff, so I might not be instantaneous.
I totally get that. Well, thank you so much, and thank you everybody for hanging out with us. We call these, work with me and AMAs because one, we want to hear questions from you, the community, but also, we also love just showing some of the things that we're working on, learning a bit more about them. And Elastic is, we're a distributed company, so we don't get to always have water cooler conversations. And, anytime I get to talk to someone from Seattle is always a huge benefit to me because I can start planning my next trip. So again, thank you so much for hanging out with us, Ry.
Yep. Cheers.